these are other things that will assist us in handling our operation. When we talk about prime numbers, prime, it means they are special numbers. But in mathematics, we talk about prime numbers as numbers which has only itself and 1 as its factors. And what do we mean by factors? That is the numbers which can divide another number. Let me start with factors of a number. Is or are numbers which divide the number without leaving any remainder. That is, it divides it perfectly. Let's look at this. If you have 6 now, and you divide it by 2, you get 3. No remainder. So 2 is a factor of 6. 2 is a factor of 6. Look at this again. If we say 6 divided by 3, we are going to have 2. So 3 is a factor of 6. But now let's do something. 6 divided by 5. 1 and remainder 1. So 5 is not a factor of 6. So we have established what a factor is now. But you know, factors for a number can be more than 1. Can be many. Let's look at this again. 6 divided by 1 is equal to 6. So 1 is a factor. But where we are going to is prime numbers. So prime numbers will have only 1 and itself as factor. Look at this. You can say 6 divided by 6 is equal to 1. 6 is a factor of 6. But when we are talking about prime numbers, it means the only numbers that can divide that number as in prime number is their 1 and that number itself. You can see that 6 divides 6 itself, 1 divides 6. But there are still other numbers that divide 6. 2 and 3 also divide 6. So 6 is not a prime number. Let's treat it. So prime numbers, these are numbers whose factors are 1 and itself. E.g. 2, 3, 5, 7, 11, etc. 13 falls into that group. 17 falls into the group. So those are prime numbers. But if you look at number 1, you cannot refer to this one as prime number. Why? Prime numbers have only 2 factors, but 1 has only 1 factor, and that is itself alone. Prime numbers have 2 factors, but 1 has only itself. That is 1 factor. And so what is the use of this prime number, prime factor, whatever? It assists us in handling big numbers. It assists us in factorizing big numbers. It makes us simplify very huge or mathematical operations that would ordinarily seem to be too large, bogus. It makes it simple. That is the essence of the factors and prime numbers and whatever. Let's look at how we can put it to use. All these prime numbers, prime factors, and factors. Now, let's talk about breaking a number to prime factors. Prime factorization. That is, breaking a number to products of its prime factors. Let's look at the number 126. And you have to break it down to its prime, to the product of its prime factors. The first number you can easily think of is 2. So, let's see. Let's divide by 2. It gives us 6 and 3. It doesn't have anything left. So it is okay. Let's do another one. 2 cannot go without remainder. 3. Let's try 3. 2, 1. You can see. No remainder again. So that is okay. 3 again. We have 7. You can see. What other factors do we have for 7? We don't have any. So 7, 1. So it means that 126 is equal to 2 times 3 times 3 times 7. You can also say 2 times 7 times 3 squared, depending on how you want to express it. So what have we done? What we have used to divide here, we have gathered together to multiply them here. We have gathered them by multiplying them here. So think about it. If I say, okay, 4, 2, if you give me 2, you understand? 2, it gives me 1. So what does that imply? It means that when I divided 4, it gave me by 2, it gave me 2. When I divided 2 again by 2, it gave me 1. So it ascended. So that means that 4 is equal to 2 times 2. That's what it means. So it means that this number I've used to divide it, by the time I merge them together by multiplication, it will give me the original number. Let's look at 24 now. 24 divided by 8 is equal to 3. You see now. And at the same time, if I say 24 divided by 4, give me 6. So what does that mean? It means that 24 is equal to 3 times 8. 24 is equal to 4 times 6. But these are not prime factors. I'm just using that one to explain to you. I'm just using that one to explain the concept of this prime factorization to you. Now, I have 24. I have 24 now. Let me divide by 3. It gives me 8. And it's equal to, so 24 is equal to 3 times 8. You get that? Now, I cannot break 3 down because it's a prime factor. But I can break 8 down. Let me break it down. So 8 divided by 4. 2. Okay. Let me break it down again. 8 divided by 4 gives me 2. So it means that 24 still equals to 3 times, what is 8 now? 2 times 4. But 2 is a prime factor, so I cannot break it down any longer. I can break 4 down. So 4 divided by 2 is giving me 2. So 4 is equal to 2 times 2. 8 is equal to 4 times 2, that's why I got it. So 24 is equal to 3 times 2. That's what is established. So this 4 now, I'm breaking it down. 2 times 2. So it's equal to 3 times 2 this power. We still get to this power. So you can see. So the essence of this prime factorization is to make it look simple, and we can use it in, in association with other numbers, maybe in addition, subtraction, division, multiplication, whatever. When you have looked at it in its prime like this, you can easily do other operations along with it easily. Now when it is still very large, with this you can easily add because you can factorize. You can do so many things. Now let's talk about highest common factor. Here. This is the highest factor common to 2 or more integers. Highest possible value of factor common to 2 or more integers. Now let's look at these two numbers, 24 and 36. 24 and 36. You see, 24 can be expressed as 4 times 6, 3 times 8, 2 times 12. 36 can be expressed as 4 times 9, 6 times 6, 3 times 12. If you look at this, yes, they both have 4. This one has 6. This one has 9. They both have 3. Yes, you can still see. They both have, this one has 6. I think the two of them has 6. You can see. This one has 9. This one doesn't have. But at the end of the day, the biggest is 12. You can see. So the highest common factor for 24 and 36 is 12. That is, it will be 1, the highest possible. But instead of just trying to, break it down like this and do double work, since you have known how to get the factors, prime factors, you can easily get the highest common factor just by breaking this one down to what's it called? Prime factor. And this one to its prime factor. You can do that. But you don't need to do that. Just take them in the table. And then from there you'll be bringing out the possible factor common to the two of them. After you have brought out the factor common to the two of them, you can multiply and get your highest common factor. Let's see how it is done. So look at this, 24, 36. Just like we did the prime factorization. Once we go in the two of them, let's try 2. 2 goes. Here, 12. Here, 18. Let's see again. What goes? 2, 6, 9. What goes again? 3. 2, 3. You can see. So, this implies that 24 will be equal to 2 times 2 times 3 times 2. This 2 is what I'm putting there. 36 will be equal to 2 times 2 times 3 times 3. This is, you can see that we have easily located the common prime factors to the two of them. And it means that the multiplication of these prime factors is giving us the highest possible common factor to the two of them. So it means that 24, what is 2 times 2? 4 times 3, 12 is equal to 12 times 2. 36 is equal to 12 times 3. So what does that give us? Hcf is of 24 and 36 is 12. So you see, this is just for explanation purpose. Once you have gotten it here, just be confident. The multiplication of all these ones is the highest common factor for the 2 or 3 natural numbers or integers. Let's see. Now let's find the Hcf of 144 and 66. That is the highest common factor. And let's do it by our first technique. 144, 66. So it's good you use the prime number or prime factor for the two of them. If there is any number you know that can go through, though might not be prime, but you know if you divide it 2 convenient, use it. So here let's use 2. I have 72 here. I have 33. 62 cannot go again. 3 can go. 3 here. I have 2, 4. I have 11. 11 is a prime number, so nothing can divide it again. 24 can still be divided, but I cannot go further than this. So what does that mean? The Hcf is equal to product of this and this, which is 6. Now, for explanation purpose, what does that mean? It means that 144 is equal to 2 times 3 times 24, which is equal to 6 times 24. 66 is equal to 2 times 3 times 11, which is 6 times 11. So you can see, 6 is the highest possible factor that is common to the two of them. So let's do one more. Now, let's find the Hcf of 84 and 512. Here too, you can read like this. 84, 512. Let's look. Either 2 or 4, whatever. It depends on how confident you are. But it's always good to go with a prime number. So let's do with 2. So this one gives us 42. And this one gives us 2, 5, 6. Let's do again 2. I have 21 here. I have 1, 2, 8. 21, 1, 2, 8. 3 goes here. 3 cannot go here. So Hcf is equal to can break them down into factors, like the initial explanation I made. Like this one now, 84, 512. You know that 84 will be 2 times 2 times 3 times 7. 512 will be equal to 2 times 2 times 2. That's it. Times 2 again. Times 2. Times, I think 2 again. Let me see. So, you can do this. And then, just take the common ones. All these other ones are not useful in this calculation. So, because you can see 1, 2, 1, 2. No 3 here. If there is 3, you will have picked it. No 7 here, you will have picked it. So, the only things we need here is 2 times 2. So, Hcf, highest common factor is 2 and 2, which is 4. So, you can see, you can break it down like this, but this one makes it simpler and faster. Because you need to crack your brain again and again to get this. Now, let's look at lowest common multiple. So, for lowest common multiple, you know when we are talking about multiple, it means a number which another number is a factor of, or which it can divide conveniently. Let's look at this number now. When you are talking of multiple, 4 is multiple of 2. Of 2. 6 is a multiple of 2. 6 is a multiple of 3. So what do you mean by multiple? Multiple is a number which this factor can divide conveniently. Look at two numbers, A and B. And let's say B is a multiple of A. That is, if I multiply A by another number, I will get B. That's what you mean by multiple. That is, if I multiply A by another integer or itself, I can get B. So multiple of a number A is another number which A can divide conveniently without any remainder. So, when you are looking at multiple, you can say 6 is multiple of 3. 6 is also multiple of 2. 4 is multiple of 2. At the same time, you can say that 100 is a multiple of 2 because 2 can divide 100 conveniently. 1000 is a multiple of 2. 9000 is a multiple of 3. Yes, 9 is a multiple of 3. 2 is a multiple of 2. 3 is a multiple of 3. You know why? If you multiply 2 by 1, you get 2. If you multiply 3 by 1, you get 3. So that's why they are multiples of themselves. Now, let's now look at the main thing, the lowest common multiple. When you have two numbers, and you want to find which number can the two of them divide conveniently, the smallest possible number that they can divide through conveniently. We use this in working of fractions and some other workings like that. But it's mainly used in calculation of fraction. Let's see. Lowest common multiple. Hcf of 2 or more integers is a number, the smallest possible number smallest possible number, which the two or more numbers are factors of, or the smallest possible multiple of the two or more numbers. Let's look at this example. For 2 and 3, LCM is 6. Why? If you look at number 2, 3 won't go there. In number 3, 2 won't go. Number what? Number 4, 2 will go, 3 won't go. Number 5, 2 can't go, 3 can't go. Number 6, 2 and 3 can divide it conveniently. And any number below that one is not will not be okay. So what do I mean? Look at this. 6 divided by 2 is giving us 3. 6 divided by 3 is giving us 2. You see? But if you say 5 divided by 2, you won't get anything. 5 divided by 3, you won't get anything. 4 divided by 2, you get 2. But 4 divided by 3, you will not get a natural number or integer. So that is why 6 is the LCM. You understand? Now let's look at how we can break it down to get for larger numbers. Now, lowest common multiple, LCM, of 2 or more integers is a number. The smallest possible, which the 2 or more numbers are factors of, or the smallest possible multiple of the 2 or more numbers. What do we mean by this? We mean that, when we are talking of Hcf, it is the biggest number that can go in 2 or more integers. That is, if you have 2 integers, n1, n2, a factor, that is, the factor of the 2 of them, the biggest possible factor, that is the number that can easily divide the 2 of them, the biggest possible, which will divide this one and this one. Though you might have another bigger one that might go in this, or another bigger one that might go in this, but that number is the biggest that will divide this one and this one conveniently. That is for Hcf, highest. But now we are talking of lowest common multiple. That is, if we have number C1, C2. You understand? C1 has so many multiples, like 2C1, 2C2, MC1, sorry. C1 has several multiples, like 2C1, 3C1, 4C1, you have NC1, etc. Or J. N can also be multiple of C1. N can also be multiple of C1. K can be multiple of C1. So for C2 too, let's look at the multiple of C2. We can have 2C2, 3C2, 4C2, N, K, J, Z. Here we can have NC2, C2 square. We can have C2 square, C2 square, etc. Like just, we can have C1 square here. But we are talking about a number which you can find as a multiple of C1 and multiple of C2 conveniently. That is, the 2 of them will divide this number. Let's say the number is Y. Which means this one can go in Y, C2 can go in Y. And at the end of the day, by the time you look at it, it is the smallest convenient number that the 2 of them will go in. They can go in another bigger number. They can go in another bigger number. That is, C2 can go in, the 2 of them can go in another bigger number. They can go in, like, okay, let's say 2Y. The 2 of them will divide 2Y conveniently. But we are saying that any number smaller than Y, the 2 of them cannot divide it conveniently. That is, even if C1 divide another smaller number, C2 will not divide it. Something like that. But this will be the smallest multiple that the 2 of them can divide conveniently. So let's see example. Now let's look at this. 63. We are asked to find Hcf and Lcm of 63, 42, and 92, 34. The reason I'm doing this is so that you'll be able to differentiate between the LCM and Hcf. But I want you to know something. Before we arrived at Hcf and Lcm, we treated how to find the factors of this number. And it is the technique of finding the factors that you have been able to derive Hcf and Lcm easily. Easily. You can go the tough way, but this technique makes it easy. How? By finding the factors, and then from there you can get it out. Let's do this too. So that you be able to differentiate between LCM and Hcf. Let's do the first one. Now we have 63 and we have 42. Now, if you look at these two, 3 You can see that 7 is a convenient number that goes in the 2. 7 goes there. 3, 2. You can see they don't have common factor again. There's no factor again. So at this stage, we can find our HCF, highest common factor. Here, you can find our HCF. So HCF is equal to 3 times 7. This is the end of the journey for HCF, where we can no longer find any factor again. But from here, we can now go on to find LCM. LCM, we divide until we can get 1, 1 under the beneath the 2. So let's see. 2 here, you have 3, you have 1. Because 2 cannot divide this one conveniently. Now let's see. 3 here, you have 1, you have 1. So with this, you can now get LCM. That is the lowest common multiple that these two will divide conveniently. Let's see. LCM is equal to 3 times 7 times 2 times 6. So what is this telling us? HCF is also a factor of LCM, because HCF is a factor of these two. Do you understand? HCF is a factor of this, a factor of this. So it is a factor of LCM. So invariably, HCF will be smaller than LCM. Now, let's see. HCF from this result. HCF is equal to 21. LCM is equal to 21 times 6, which is 1, 2, 6. That is a very easy and convenient way of getting it. Now, another way is to express the factor. Express each in factor, and from there, you carve out your HCF and LCM. Let's quickly do that. Now, let's see. This one is equal to 3 times, let me put it like this, 21 for ease. This one is 2 times 21. So from here, you can even see we have gotten our LCM, because these two are common. You can see. So for LCM, you can easily get it. Although we don't break it down to the final thing, but you can still do it if you have not, if it's another number you have not gotten. So let's do it like this: 3 times 3 times 7. 2 times 3 times 7. So the combination of these two, because they have common factors, so this will give you the HCF. Is equal to 3 times 7, which is 21. Or from here, you've gotten it directly. Now let's look at LCM from here. Now these two, it is just like compiling sets, in which you cannot count one twice. The common ones, you should not count them twice. So you count this out, you count this out. From there, let's bring the common ones out. 3 times 7. Now, the ones that we do not circle together, let's bring them out now. 3 times 2, which is 6 times 21, 1, 2, 6. Do you understand now? So from here, we now bring this one here. We first of all gather the like ones, the common ones. Those are these two. You understand? We express them once. The ones that are not common, we now put them there. That is for LCM. Please note. That is for LCM. But for HCF, only the common ones are the ones we are bringing out. Then I believe this one has explained. Let's quickly do the second one. Now let's quickly do this. Here, let's divide by 2. 4, 6, 1, 7. 4, 6, 1, 7. What else can we? 17 is a, what's it called? Prime factor. 17 is prime factor. So nothing can divide this one again. So let's leave it like this. So from here, nothing goes again. So our HCF is equal to 2. You can see our HCF is equal to 2. Now, so but LCM journey does not end here. I told you until the 2 we get 1, 1 below. That's when LCM ends. Let's quickly do this. 17 here. This one will be 46 because 17 cannot divide 46. So this one will be 1. Now again, you can put 46 straight since we are not competing between two numbers again. So 46 here. So our LCM is equal to 2 times 17 times 46, which is 34 times 46. And so that is 1564. Now let's look at it in this breaking down in factor form. You understand? As product of the factor. So this one will be 2 times 46, and that is 2 again times 23. 23 is the prime factor. This one is 2 times 17. You know I told you this one will be once. This one will be once. And from there, you'll be able to get this, and this. These ones are expect once. But since this one is common, we bring it out. So HCF from here is equal to 2. is based on the technique of breaking them down into their factors. That is all. Even the one with line is breaking it down to factors. And from there, we know where we can get our LCM and our Hcf. Thank you very much. Kindly subscribe, share, comment, follow. If anything, advice you believe you can use, please, is welcome. Thank you very much.